Elementary Calculus. Today your learning target is I can solve equations with complex solutions. It should say I can solve quadratic equations with complex solutions. So what I'm going to do first is kind of just remind you from Algebra 2 what quadratic equations are, because it has been a while. When you hear me say the word quadratic equation, basically all I'm talking about is an equation that has x to the second, or a variable squared. So you're looking for a power of 2. Standard form is ax to the second plus bx plus c is equal to 0. The a, b, and c in this form are numbers. A is the coefficient of the quadratic term, b is the coefficient of the linear term, and c is just a plain number called constant. So we're going to take time to write that down. This is the quadratic term. The bx is the linear term, and the c is called the constant. It's just a plain number. In order for a quadratic equation to be in standard form, not only does it have to obviously have a power of 2, but it has to be set equal to 0. So when you're solving quadratic equations, your equation must look exactly like this. From Algebra 2, you learned different ways to solve quadratic equations. You should have learned how to solve them using factoring, graphing, and then what's called the quadratic formula. Recall from Algebra 2, the quadratic formula is just a way for you to basically help you find the x variable in the quadratic equation. So what I've starred here is the formula that you have to have memorized. It is always on the ACT as well, and they don't give you the formula, so they just expect you to know it. In order to find the solution for x in a quadratic equation, you can use this formula for every single one of them. X is equal to negative b, and b stands for, again, the coefficient of the linear term, plus or minus the square root of b to the second minus 4 times the value of a, which is the coefficient of quad, times the value of c, which is the constant. You're going to divide all that by the value of 2 times a. The part that is underneath the square root, part that is underneath the radical, is basically called the discriminant. And discriminant is an important word here. Discriminant. The discriminant is the number under the radical in the quadratic formula. The discriminant will tell you what type of solution you're going to get and how many solutions you will have. So this is just a reminder from Algebra 2. If the discriminant, and I'll abbreviate here, if the discriminant is greater, just use my pen here, if the discriminant is greater than 0, basically if the discriminant is positive, then you're going to end up getting 2 real solutions. You will have 2 real solutions for the quadratic equation. If the discriminant is less than 0, In other words, if it's negative underneath the radical, you will get two imaginary solutions. And then last year you learned that if the discriminant is equal to 0, you only have one real solution. Okay, and again, all of this is just review, but the reason it's showing up in this unit for us, since we're talking about complex numbers, is this scenario. So, since we're practicing today on how to solve quadratic equations with imaginary solutions, we would expect, if we do use the quadratic formula, we would expect the discriminant, this piece, to end up being negative after we simplified. And so you're going to have to use PEMDAS. You're going to have to use order of operations to work this problem out. Always do the discriminant first, figure out what that type of number it is, so that way you can kind of make the call. You're going to square first, multiply second, then subtract. You end up with one single number. Then you'll have values for B and A. You'll simplify the entire radical as best you can, and that should tell you what your x is in this equation. So all of what I've shared on the first screen basically is a review information. You've had it before, but the part I've highlighted here is the reason it's showing back up in this unit. So solving quadratic equations with imaginary solutions, you're going to use the quadratic formula when you can to determine the solution. If the discriminant is a negative number, again this is just repetitive, then you're going to expect two imaginary solutions. And I have that quadratic formula back on the screen, and I have it highlighted, super important. Example 1. Solve 3x to the second minus x plus 2 equals 0. First, you need to make sure you understand it is in standard form. You have the quad term first, linear term second, and constant third. Your job is to list your A. A is the coefficient of the x squared, B, which is the coefficient of the linear term, and C, which is just the constant. Okay, so my suggestion is you always write those down. Then you're going to go back to the quadratic formula, and you really want to use the quadratic formula, especially when you already have all three terms in front of the equal sign. That's when it's really important. So when you have a problem that's in standard form, you need to use quadratic formula. All right, so I'll write the formula back down one more time. X is equal to negative b, and it's plus or minus the square root of b to the second minus 4ac all divided by 2a. Okay, and then your job is to substitute all the values, 3, negative 1, and 2, in place of these letters. And here we go. So the next step is going to look like this. X is equal to negative, and b is negative 1. There'll be a plus minus sign there. And type it like that. And then you'll have the square root symbol. My suggestion is always put the b in parentheses, especially if it's negative, so you enter it in your calculator correctly. And then minus 4 minus 4 times a, which is 3, times c, which is 2. And then it's divided by 2 times 3. Get all the notation before we move on. There's my big square root symbol. And so when you're looking at the next step, you would always want to simplify. I'll go ahead and just simplify this piece and call it x is equal to negative 1 becomes positive 1, and then plus or minus, and then you're going to stick with the square root symbol. You're going to do PEMDAS underneath, so powers first. Negative 1 times itself. That's why it's important to use parentheses here. Negative 1 times negative 1 is positive 1. Some people like to think of this like a negative sign, and some people want to bring it down as a minus. That is completely up to you. I'll just bring it down as a minus sign. And then my eyes need to be focused on these 3 numbers to multiply. So it's 4 times 3 times 2, and that's going to be a 24. And then the big division bar, and then 2 times 3 is 6. Okay, we continue to simplify. So x is equal to, we have the 1 plus or minus the square root, and 1 minus 24 is a negative 23. And then it's divided by 6. And so right now we kind of pause just for a second and we make sure we understand that this number is actually the discriminant. And because that discriminant is negative, we would expect 2 imaginary solutions. And so to continue to finish this out, you would say x is equal to 1 plus or minus, and then you're going to do what we did the other day with simplifying radicals with negative numbers. You're going to pull out the negative 1, bring down the next number, 23. You're then going to have to think about the perfect squares in your head and think about a number that 23 goes in, or a number that divides into 23, I should say. 4 does not divide into it, 9 does not, 16 no, 25 is too big. So that basically means 23 is not divisible by any perfect square. What that means is it's going to have, this part can come outside, this part's going to have to stay. So x is equal to, you're going to have a 1 plus or minus, and then that part is I, radical 23, and then divided by 6. And so there are supposed to be 2 imaginary solutions, and there are right here. That's why the plus minus is involved in the formula. So one of the answers is 1 plus I radical 23 over 6, and the second answer is 1 minus I radical 23 over 6. So you're going to have to take each of the quadratic equations if it's in the right form. You're going to need to list your A, B, and C, write down your quadratic formula as your guideline. The more you write it, the better you'll remember it. And then start substituting these numbers in the appropriate places. Use PEMDAS, order of operations. A lot of these will simplify to like a negative number, and that's, again, why it's in this unit. We're practicing imaginary numbers. You'll have to factor out negative 1 and simplify this as best you can. Make sure it's simplified form. Okay, on your screen right now you see the second one. I'm going to have you write that down in your notes, and then you work it out using the same process I did for number 1. X squared minus 4x plus 5 equals 0. So you need to do that one. Okay, we got a couple more things. On your screen now you see example 3, and it just says solve. And one thing I notice about this one is I see a quad term and I see a constant, but it's missing the x to the first. And so problems like this, you actually have an option. You can put a big 0x in here if you want to, and you can do the same problem, the same method that I did for example number 1, using the quadratic formula, because quadratic formula will work for every single quadratic equation. That's the nice thing about it. However, there is a faster way to do a problem of this nature. So that's the reason I'm showing you this. If you have a quadratic term and a constant term, instead of going through the quadratic formula, what you could do, and again, the process I'm showing you only works if the linear term is missing. The process that I'm getting ready to share with you only works when there is not an x to the first in your problem. You can just transpose. You can call this x to the second is equal to, drop your 0 if you want to, 0 minus 49, but I'm just going to leave 0 out and just move the 49 over and call it negative 49. And if it's a quadratic equation, you also learned that the opposite of squaring a term is taking the square root. So we are allowed to take the square root of both sides, like that. That's going to allow the x to be by itself, which is what we want. And then this problem is the same as problems we've worked in the past. Square root of negative 49 does not have a real answer. Your job is to write it as negative 1 times 49. And then x is equal to, this is the imaginary part, square root of 49. 49 is a perfect square, so that works nicely. 7 times 7 is 49, so the 7 is going to come on the outside. This piece is going to be I. And there are actually two answers here. It could be a positive or a negative. Remember, all quadratic equations, because of the power, the degree, if it's a power of 2, you should expect 2 solutions here in this type of problem. So don't forget that plus minus on your answer. Okay, and then example 4, this will be our last one today. We have 5y to the second plus 2500 is equal to 0. I do see a quad term. I do see a constant term. I see equals 0. It is missing linear term. So I'm going to choose not to do the formula. I'm just going to transpose and get y by itself. So I'm trying to figure out a way to get this term by itself. First thing I'm going to do is move the 2500 across. So it's going to read 5y, let me try this a different way. So it's going to be 5y squared is equal to negative 2500. Then you're going to divide both sides by 5. You're going to next get the y squared, bring that one down. Equals, and then negative 2500 divided by 5 is going to be negative 500. Okay, next step, we still need to get rid of the power of 2. So we're going to do the opposite of squaring, which is taking the square root of both sides. Okay, y is going to be left by itself, which is what we want. You're going to then have the square root, and you're going to have a negative 1, and then times 500. Okay. Alright, so I'm going to put a little times sign there, bring this over. Okay, and then before I forget, let's go ahead and put that little plus minus sign in there, because anytime you take the square root of both sides of an equation, quadratic equation, again, there are 2 solutions. And then you're going to bring down your y, and you're going to bring down your equal and your plus minus. And then the next thought should be, okay, I see that imaginary number there. 500, you're going to go through your perfect squared list. 500 is, once you make that list, it's not in there, so you're going to have to write it a different way. You're going to have to pick the biggest number that will divide into 100 or 500, and that would be 100, because 100 is a perfect square. So write it as -1 times 100 times 5. Okay, here's my imaginary part, and here's my real part. And so I'm going to finalize this by saying y is equal to try this again. Y is equal to positive, negative, square root of 100 is 10. The square root of -1 is imaginary. And the 5 is going to have to stay underneath the radical. And so this is my finalized solution set. The problem was wanting me to find y. It was a quadratic, so I would expect two solutions, but they're both imaginary. Okay, so make sure when you're solving that type of problem, you can use the quadratic formula if you wish, but usually this method will get you there faster. Again, you can only do the transposing part, like example 3 and example 4, if it's missing a linear term.